The IMABS function within Excel allows us to take the absolute value of a complex number. Now, when working with real numbers and then we take the absolute value of such a real number, we might think it's just taking the positive value. So -4 becomes 4 and 4 remains 4. But actually what it means, it is the distance from that point to 0. So the distance between -4 and 0 is 4, and the distance between 4 and 0 is also 4. So when we are taking the absolute value of a complex number, it's much better to think of it like the distance between that point and 0. Now, as you might know, a complex point can be plotted on the complex plane, where the x-axis represents the real part of the number and the y-axis represents the imaginary part of our complex number. So when it's plotted, we will be calculating the distance from that point to the center, which is 0, 0. Now we can very simply do this using the IMABS function within Excel. So I write =IMABS, and I only need to supply one number, which is a complex number. So in column A, I have some complex numbers consisting both of real and imaginary parts. The part associated with I is the imaginary part. This I equals the square root of -1, and it can also be represented with a j, which is often done in electrical engineering. Now do keep in mind that these complex numbers are to be considered text or string in Excel, and that is the reason why we cannot use a regular ABS function, as that would require a numeric argument, whereas with the IMABS function we can supply a complex number as string or text. Okay, I close the parentheses, I press enter, and I pull this downwards. And so what we are getting is the distance from our complex point to the center. And you can see for some of these points we get nice and clear results, such as 2 is 2 away from the center. That's obvious. One thing you can see here as well is I is 1 away from the center. That's right, because I is just 1 unit above the center on the y-axis. Okay, but how was this absolute value actually calculated? Well, like I mentioned earlier, the absolute value of a complex number is the distance from that complex number on the complex plane to the center of the complex plane. And so when we are calculating a distance, we can use the following formula, which is x squared plus y squared, and of that we take the square root. This is derived from the Pythagorean theorem. Okay, let's give this a shot. So we use the sqrt function. Now we can use the regular square root function in Excel, and we don't need to use the msqrt function, as we will be working with real numbers here. Now the first argument here is x squared. Now x represents a number on our x-axis, and remember the x-axis on the complex plane represents the real part of our number. So to extract the real part from our complex number, we can use the mreal function, and then we supply only one argument, which is the complex number. I close the parentheses and I bring this to the second power. Now I add to this y squared. Now y represents the y-axis, and this is the imaginary part of our complex number. So with the imaginary function, we can extract the imaginary coefficient of our complex number. So the only argument is the complex number, and I also bring this to the second power, and I close the parentheses and press enter. Now I pull this downwards, and as you can see, we are getting exactly the same result, because, like I mentioned, taking the absolute value of a complex number is the same as calculating the distance from that point to the center. Now the absolute value of a complex number, we call this also the modulus, because it can also be used to write our complex number in a different form. The form you see in column A is what we call the rectangular form. So you have the real part and the imaginary part, and they both contain a coordinate on which we plot the point on our complex plane. Now we can also use the exponential form. With the exponential form, we use the argument, which is the angle at which the point is rotated from the x-axis on the complex plane, and we also use the modulus, which is the distance from the center to the complex point. Knowing those two variables, you can also uniquely identify a point on the complex plane. Now the formula to write this point at is r times e to the power theta I, where r represents our modulus, or the absolute value of the complex number, being the distance from the center to our complex number, and theta represents the angle or the argument at which we can find that point. Okay, so let's write this then. So it would be r. Now r we've already calculated using the IMABS function. Now I will be rounding this down to 2 units. So we take the argument of the IMABS function and round it down to 2 units. Then I will concatenate this as strings to e to the power of, and then theta I. Now theta is the argument, and we can calculate this using the IMARGUMENT function. But I will also be rounding this down to 2 units, so I will use the round function, and the argument to the round function will be the IMARGUMENT function. So we will be calculating the theta, or the angle, and we take the angle of our complex number here in column A. I will be rounding this down also to 2 digits, and then I will be concatenating this with the letter I. I press enter, and there we have our complex number in the exponential form. Now let's use this exponential form to get back to our original complex number. Okay, so what we do is we take the modulus, or the absolute value of our complex number, which we've calculated using the IMABS function, and we multiply this with e to the power of theta I. Now this means we need to take the exponential of theta I, and since I is a complex number, we will have to use a special Excel function, which is called the IMEXP function, which will return the exponential of a complex number. Now here we have to provide an argument of the complex number. And so this will be theta I. Now, like I mentioned earlier, we can calculate theta using the IMARGUMENT function. So that's what I will be using. And I supply it with the complex number. Now I will need to multiply this with I. So for this, I will use the IMPRODUCT function, which allows us to multiply 2 complex numbers together. So the first number we will be multiplying is the argument of our complex number, and I multiply this with I, which I put in between double quotation marks. Now I close the parentheses, and if I now would press enter, we will actually be getting an error. I'll show you. We get a value error. And the reason why that's happening is because we are multiplying a real number with a complex number. And like I mentioned earlier, complex numbers are considered to be text in Excel. So we cannot use this asterisk here to multiply our modulus with e to the power theta I. We also need to wrap this in the IMPRODUCT function. So I use the IMPRODUCT function, where the first argument will be our modulus, and the second argument is e to the power theta I. So then I close the parentheses, press enter, and there we get the result. Let's pull this downwards, and as you can see, we are getting back to our original complex number. Now, there are some rounding errors down here, but in essence, this is still the same number. You can see, for example, here we have e to the power minus 15. Well, that means there are 15 zeros in front of this decimal number. It's like 0.00000, etc. plus 2i. So in essence, that's 0 plus 2i, or 2i, which is here the complex number we started with. So whenever you need to take the absolute value of a complex number, or you need to calculate the modulus of a complex number, you can use the IMABS function, supplying a complex number, and out will come the absolute value of that complex number. Thanks for subscribing, and leaving an optional tip. Consider watching this video next.